Hello everyone, welcome to my channel. This is 𝐂𝐥𝐿 and in today's video I'll explain you how to create a Google Kubernetes engine on Google Cloud using Terraform. So in previous video I explained you how to create a GKE cluster manually. So in today's video I'll explain you how to create a GKE cluster using Terraform. So here you can see this is my Google Cloud console. So first let's navigate to Kubernetes engine. So let's wait. So directly select here clusters. So here you can see currently I don't have even single Kubernetes cluster. So now let's create it using Terraform. So let me close this and let me create an empty folder. Let's name it like GKE hyphen folder and let me open VS Code in file open folder, and here let me select my folder which is GKE folder. So in this folder, let's create entire files for Terraform. Okay. So initially when we are working with Terraform, so initially we need to provide provider.tf file. Okay. So directly create a file with name provider.tf. So here .tf extension nothing but Terraform guys. So if you are working with Terraform, you need to give extension with .tf. So let me open a new tab. So let me drop down this. Let me open a new tab. So here search for Terraform code for GCP provider. So let me open this link. So directly select your use provider and directly copy this entire thing. Okay, directly copy this and come to VS Code and paste it here. So here you can see we are using Terraform and provider as Google, required provider is Google and HashiCorp Google. So this is the version we are using. So inside this we need to provide our Google cloud configuration. Okay. So let's select here project and let me open my Google Cloud console and directly select this. So from here you need to copy your project ID. So I'm going to create my Google Kubernetes engine in this my first project. So I'm going to select this project ID. So I'll come here and I'll paste it here. Okay, so this is the project ID. Now let me keep like this. Okay, now region. So in which region we want to create this infra, it is asking. So I want to create this on US Central 1. Okay, so now same like this zone. So I want to create on US Central 1A. So I want to create this GK in US Central 1A. Okay. So after that, we need to provide credentials. So these credentials is used to authenticate with our Google Cloud account. Okay. So now I'll explain you how to get these credentials. So directly open this Google Cloud console and directly navigate to IAM and directly select here service accounts. And let's create a new service account for today's video. So directly select here create service account. So let's give the name like GKE hyphen service hyphen account. So I'm going to create a service account for my Google Kubernetes engine, right? So that's why I'm giving GKE service hyphen account. So here you can give the name whatever you want. So directly select here create and continue. And here provide the role. So I'm going to give basic and I'm going to provide owner permissions for this service account. And directly select here continue and directly select here done. Okay. So now our service account has been created, guys. Okay. So let me show you that GKE, right? So here you can see GKE hyphen service hyphen account. So this is the service account we created. So if you want to see the IAM rules for the service account, so directly jump onto IAM and directly come down and here you can directly see the service account, which is GKE-service account. So here you can see GKE-service-account. So for this, we have given owner permission role. Okay. So if you want to add some another roles, you can directly select this edit, and you can directly select here add another role. And if you want to provide some artifact registry type of roles, directly search for artifact. So here you can say artifact registry admin. You can directly select this, and you can directly select here save. So it will you can add some roles like this, guys. Okay, that's what I'm going to explain. So for now, I have given owner permissions. This is enough for us. Okay, so let me create a JSON file for our service account. Directly select service accounts and open the service account GKE-service-account, and directly select here keys, and here directly select add key and create new key. So directly select your JSON and create. So this JSON key is used to authenticate with our Google Cloud account, guys. So using this service account JSON file only, we are going to authenticate with our Google Cloud account, and we are going to create a GKE cluster. Okay. So it is downloaded to our local machine. So let me select here downloads. So here you can see it is downloaded. So let me refresh this page. So here you can see this is the JSON file we have created. Okay. So after completing your labs, directly delete this JSON file, guys. Okay. So now let me come here and let me copy this and let me keep it here. Okay. So in this JSON file, it was having the service type as service account, and this is our project ID. In this project only, we're going to create our Google Cloud account, sorry, GKE cluster, and this is the private key ID, and this is the private key, and this is the client email, and this is the client ID, and this is the authentication URL, and this is the token URL. So this all fields are required to authenticate with our Google Cloud account. Okay. So let me rename this to keys.json. Okay. So now let me open this provider.tf file, and let me select /keys.json. Okay. So now if you want to pass these values from variable.tf file, directly create another file with name variable.tf. Okay. Now directly select here variable, and variable name, let's give the name like project. Let's come down. So here description. So let's give the description name like this is GCP project ID. Okay. So let's give like this, and type. Let me select this, and type is string. Now default. From here, let's copy this project ID. Copy this, come to variable.tf file and paste it here. Okay. So now let's remove this entire thing. Variable dot project. So from this variable.tf file, it will take this project. Okay. So now let me copy this. Let me paste it here. So next is region, right? So region. This is GCP region. Let's give the description like this is GCP region, and type is string, and here US Central 1. Okay. So now here we need to remove one is okay. Here zone. This is GCP zone. Let's give the description name like this is this GCP zone, and here value default value is US hyphen central 1 hyphen A. So I want to create my GKE cluster on this zone and on this region. Okay. So let me come here where dot region, and here where dot zone. Okay. So try to maintain variable.tf file also, guys, so that will be some easy. So now let me run this two files. Okay. Run add to file. So now one thing I forgot it, guys. Okay, so if you want to store your backend configuration on a Google Cloud Storage bucket, you can do that. Okay, so directly come here and directly search for cloud storage. So it is similar to AWS S3. Okay, so let me open this. Let me come here. So directly select your buckets. So here you need to create a bucket. So directly select here create. So here GKE hyphen bucket. Okay, or else GKE Terraform bucket. So let's give the name like this and directly select here continue. Okay, taken -001. So let's give like this. Okay, so I'm going with multiple region and continue and directly select here continue and continue and at last create. Okay, so now we are going to store our Terraform state files in this bucket. Okay, so currently we have created this bucket, right? So let me open VS Code and let me write a backend configuration. So backend.tf. Okay, so in this backend.tf, let's create backend configuration. So Terraform, and we are going to use backend as GCS Google Cloud Storage. And here we need to give the name of the bucket name. So this is the bucket name. Copy this, come to VS Code, paste it here. So remove these spaces, guys. Okay, now it is okay. So prefix. So I want to store my state files inside Terraform and inside state. I want to store my state files in this path. So here again credentials, you need to provide your Google Cloud credentials, which is keys.json file. Okay, so this is the file you need to provide. Okay, so now let's run this entire thing. Okay, so before running this, here you can see we don't have even single path. Okay, so when we are going to execute this, it will create Terraform slash state. Okay, inside that we are going to create it will create Terraform state configuration. Okay, so let me run this file. So okay, we are inside this path. So initial command is Terraform init. So it is used to initialize without Terraform. So here you can say successfully configured the backend as GCS. Terraform will automatically use the backend unless the backend configuration changes. Okay. So now this Google Cloud Storage bucket is used to store our Terraform state files. Okay. So similarly in AWS we use AWS S3. Okay. So it is done. Okay. So let's open this and let me refresh this. Let me refresh this page. So here you can see Terraform and inside state will be created. So inside this, our state configuration will be stored. Here you can see default.tf file. So in this file, our state file will be stored. Okay. So now let's create our main configuration. So let me create a file with main.tf. So from now, the entire code will be starting as that means from now we are going to create a Google Kubernetes engine, not Google Kubernetes engine. We are going to create a private Google Kubernetes engine, guys. Why? Because means we are going to create a VPC, subnet, firewalls, and we are going to create a GKE cluster. Okay, we are going to create entire this using Terraform. So initially, let's create a VPC. So let me open the new tab. Okay, now search for Terraform code to create GCP VPC. So directly search like this and open this first link. Directly come down and directly copy this, guys. Okay, directly copy this file and come to VS Code and paste it here. So now here uh, we don't need this project. So why? Because means we have already given this project details and everything in this provider.tf file, right? So we don't require here. Okay, so let's give the name like virtual network name like custom VPC. So before creating this, let's check whether we have that custom VPC or not. So let me directly jump onto VPC network. So with name custom VPC, we don't have even single VPC. Okay. So now we are going to create a VPC first, which is custom VPC. And here auto creation subnets, let's select here false. So we are going to create our own subnets, right? So that's why I'm going to select here false. So MTU, this is unnecessary. So let me remove this. Okay. So by default, it will take that everything. Okay. So now let me create a subnetwork for this VPC. So let me open a new tab. Now search for Terraform code to create GCP subnetwork. Open this first link. So everything you can directly refer this official Terraform documentations, guys. Okay. So in real time also, most of the people use only Terraform official documentation to write this Terraform scripts. Okay. Just remember that thing. So directly paste it here. So I'm going to remove the secondary IP range. So this is not necessary. So now let's give the subnet name like custom subnetwork. Custom subnetwork. So let's select a region as US Central 1. Okay. So let me open this region US Central 1. Okay. So here you can say I have given some wrong. So that's why I checked this. Okay. US Central 1. So you need to provide same like this. So now let me come here. So instead of this, let's take from variable.tf file, where.region. Okay. So now CIDR, let's give 10.10.0.0/16. Okay. So I'm giving this CIDR range. So now here you need to provide a network. So in which network you want to create, it was asking. Now Google Compute Network dot. So I want to create under this VPC network. So VPC network dot ID. Okay. So same. Now this sub network will be created under this network, guys. Okay. Now we have given name and region. Okay. Now let me create a firewall rule. So directly open this. Terraform code to create GCP firewall. So open this first link. Directly come down. Now directly copy this. Okay. So this resource is used to create GCP firewall rules. Okay. So let me come here. Let me paste it here. So here let me change this name to so first let's change this name. So let's change everything, guys. Okay. So let's keep here custom and custom dot id. Let me provide like this. So we are going to we have create up to now we created a VPC and we created a sub network. Uh, okay. So this is the tag name I'm giving. So now let me create a firewall rule. So for today's video, I'm going to create three different firewall rules. One for internal communication, and one for SSH and RDP, and one for kubelet API communication and Istio control plane communication. Okay, so I'm going to create three different firewall rules. So now first firewall rule I'm going to create for internal communication. So that's why here I'm going to provide hello internal, and here let's give the name like hello firewall, or else let's give the name like internal firewall. So this will be better. So now in which network we want to create, it was asking. So now I want to create under I'm going to create under this network. So that's why we need to provide this name. Google Compute Network dot custom network dot ID. Okay. So same like this you need to provide. So now this firewall rule will be created under that network. So here ports is all I'm giving. So this is for internal communication, right? So that's why I'm going to select ports as all. So let me remove this. We don't necessary this. So source tags, so we don't need this. Instead of source tag, let's do source range. Okay, source range is let's give this range. Okay, 10.10.0.0/16. So let me copy this. Let me paste it here. Okay. So now we are going to provide internal communication for this. We are going to use this firewall for internal communication. Okay. So now let me create another firewall. So same again, I'm going to copy this and I'm going to open VS Code and I'm going to paste it here. So let me use spaces. Okay. So now this firewall rule I'm going to use for external access. Okay. So that's why here I'm going to give external and here external firewall. Sorry. So let me remove this entire thing. Hello external firewall. Okay. So I want to create this under custom network dot id. Okay. So I'm going to create this under this custom network. So every firewall we are going to create under that network only. Okay. So for this firewall, I'm going to allow ICMP port, which is for ping. So here I'm going to remove these ports and I'm going to provide only SSH, which is port 22, and another port is for RDP, which is 3389. Okay, so I'm going to provide this. So now I'm going to remove this. Instead of this source ranges, let's provide like this. So now 0.0.0.0/0. So okay, so I'm going to provide this so anyone can use this. Okay, so now here let me add some tag comments like firewall one. Okay, so let's give like this. So this will be better. Firewall two for uh, external access. Okay, so now let me create another firewall rule. So here what we are providing SSH, ICMP and RD. Okay, so these are the firewall rules we are going to accept for this. So now let me create another firewall rule. Let me copy this up to here. Let me paste it here. So now let me remove this firewall 3 for GKE communication. Okay, so now here let's give the name like 𝐂𝐥𝐿 GKE firewall. So this is the firewall name. Okay, so this also we are going to create under this uh, VPC network. Okay, so now here let me remove ICMP. So previously we have given this, right. So we are going to use this which is TCP port 443 for HTTPS communication, and here 10250. So 10250 port is used for kubelet API communication. Okay, so now let me provide another port which is 15017. Okay, so this TCP port is used for stereo control plane communication. Okay, so these are the three firewall rules we created for our VPC network. Okay, so now let me create a port for Google Kubernetes engine. So let me create GKE cluster. So this is the name. Okay, so now let me open this. Let me open a new tab. Now directly search for Terraform code to create GCP GKE cluster. Okay, so directly search like this. and directly open this first link and directly come down. So service account, we don't need this. Okay. So here you can see Google Container Cluster. Okay. So we need this and we need Google Container Node Pool. Okay. So this is not necessary, guys. So if you are going to create only with Google Container Cluster, so if you are providing this block, it will create with a 3 node Kubernetes cluster. Okay. So if you want with the default node pool, like you want to give your own configuration and you want to create with 2 node or 4 node or 6 node Kubernetes cluster, you can directly provide this node pool. Okay. So in this video, we're going to create that everything. So let me copy this first. This is for GKE cluster. Okay. Let me paste it here. So now first let's write this everything. So let me remove this entire thing guys. Okay. So I will explain you everything. So first we are going to create a Google Kubernetes cluster, right? So that's why initially we need to provide project. So in which project you want to create, it was asking. So I want to create under this project, where.project. Okay. So let me open this variable.tf file. So we are going to create this under this project. Okay. So now let's provide name. So here let's provide Kubernetes cluster name like uh, Terraform hyphen GKE hyphen cluster. Okay. Sorry. Okay. So let's give the cluster name like this and cluster location. So we need to provide cluster location. So let me open this and US Central 1. Okay. I want to create this under US Central 1 region. So let me come here. Region. Okay. So it will this Google Kubernetes cluster will create under this US Central 1. Okay. So now let's come here. Now we need to provide networking details. Network equal to Google Compute Network. Okay. So we are going to create this under this VPC network. So that's why Google Compute Network dot custom network dot ID. Okay. So you need to provide like this dot ID. Okay. So now this GKE cluster will be created under that custom network. Okay. Now sub network Google Compute Network dot custom subnet dot I. Okay. So now we are going to use subnetwork as this. So min master version. Okay. So I will do one thing. Let me open this variable.tf file. Let me copy this. Let me come here and let me paste it here. So let's give the name like Kubernetes. Okay, Kubernetes version. So this is the GKE version. Okay. So here we need to provide the value. So now var.kts version, var.kts not project. So if you don't know how to get this version, okay, so I will explain you that. So you can get this Kubernetes version from this Kubernetes console only, guys. So directly jump on to GKE, directly search for GKE, Kubernetes engine, directly open this, directly select your clusters. So directly select your create. So we're going to create a standard cluster. So I'm not going to create a Kubernetes cluster, but I'm going to explain you from where we can get that Kubernetes cluster version. Okay. So here you can see this is the one. Directly copy this. Here you can see, so this is the latest Kubernetes version, guys. Okay. So if you want some previous versions, you can directly copy that versions from here. Okay. So I'm going to take the latest Kubernetes version. So that's why I'm going to copy this and let me open this variable.tf file and let me paste it here. Okay. So Now this Kubernetes cluster will be created on under this version. Okay. So let me cross check this 1.0.2.0.0.0. Okay. So, one thing again, I want to tell you. So, if you don't, if you are not providing this, so if you are commenting this like this, so it will create with the latest Kubernetes version. Okay. So, if you want to create with some old Kubernetes versions like 1.29, 1.28 like that, so you can directly add that version here. Okay. So, you can directly add that version. So, automatically it will create using that version. Okay. So if you want to create with the latest Kubernetes version, directly comment this. So automatically it will create with the latest Kubernetes version. Okay. So now mm, we come here. So deletion protection. Let's select here false. Okay. And deletion. Let me select this. Okay. So now remove default node pool. Let's give true and initial node count. I need with two node Kubernetes cluster. So that's why I'm going to provide here two. Okay. So let me remove this. Okay. So, so this is only the GKE cluster Terraform resource, guys. So that means this configuration is enough to create a Google Kubernetes engine. So this will create with the uh, three node Kubernetes cluster. So if you want to add some node pool, I will explain you that now. Okay. So let's come down and directly come here, open this link. So this is the Terraform resource to create a node pool. Okay. Directly copy this up to here and come to VS Code and paste it here. So now we don't need this service account details. Okay, so I'm going to remove this and let me write this entire configuration. So name. So it was asking what name you need to provide for this node pool. So I'm going with this name, with the same name, my node pool, and I want to create this under. So let me remove this. Okay. So project again. So it was asking, so in which project you want to create. So I want to create this under this project. Okay. So let me copy this up to here. Project. Okay. So now this container node pool will be created under this project. Okay. So this project we are going to take this from variable.tf file. Okay. So this is the project ID. So you can directly take from variable.tf file or else you can directly use from your previous Google container cluster. Okay. So I'm going to use from this Google container cluster. Okay. So now we need to provide cluster. So here again, let's do Google container. Okay. So for not this. Okay. Let me copy this. I want to provide this name. Okay. So we are going to provide this same name. Where is this? So here you can see this is the name it will take. Google container cluster dot primary dot name. So it will take this name. Okay. So now location here instead of project location. Okay. So now this location will be it. So it will take this location. So here we are going to take location when variable.tf file, right? So in variable.tf file we have given location like US central one where dot region. I think so. So here you can see where dot region. So it will take US central one. So we are going to provide node pool location from GKE cluster. Okay. So you can provide like this, or else you can directly take from variable.tf file. Anything is no problem, guys. Okay. So now version again, same like this, guys. Create as version. So if you want to create this node pool in any of the Kubernetes version, you can directly provide the Kubernetes version here. So while you are going to create a Kubernetes cluster manually, you need to provide all these details. So in previous videos, I explained you now this everything, guys. So if you haven't watched that videos, please do watch that videos first, and after that come to this video. So here you can see when we are going to create a default pool, so control plane, it was automatically taking this Kubernetes version only. So that's why here I'm going to take that version from this variable.tf file. So let me come here. Okay. So if you are not providing this, it will create with the latest Kubernetes version. So if you are commenting this, it will create with the latest Kubernetes version. Okay. So let's remove this. So now node locations. So in which locations you want to create this Kubernetes cluster? It was asking. So I want to create under US Central 1. Okay, so I want to create this Kubernetes node pool under US Central 1A. So now here again, node count. So let me write a variable.tf file for this. This is GKE node count. So now this is not a string, so this is a number. So I want to create with the two node Kubernetes cluster. Okay, so node count var.node count. Okay, so now we are going to create this container node pool with a two node Kubernetes cluster. Okay, so now let's provide this node configuration. Okay, so image, let me remove this too. Okay, so let's like write this everything from scratch. So I want to create this node configuration. So I want to provide this images Ubuntu container take. Okay, so if you want to see these details from where you can get, you can directly open Google Kubernetes engine and directly select here nodes. So here you can see image type, it is asking first. Image type we are going to use Ubuntu container ready. So if you want to provide some another image types, you can directly copy from here. So currently I'm using this Ubuntu container ready, and after that let me come down. So here you can see we are going to provide this same Kubernetes node group version. Okay, so already we have provided that. So here you can see where dot not this. So you can see where dot Kubernetes version. So we are going to provide this same version. So here you can see automatically here you can see that same Kubernetes version. Okay, and after that we need to provide machine configuration like what is the machine type and disk type, and after that we need to provide disk storage and everything. Okay, so we need to provide all these details in Terraform scripts. Okay, so let me come here and let me open this main.tf file, and after that let's select disk size. So I want to create with minimum 20 GB each disk. Okay, so disk type I want to create with PD standard, persistent disk standard. Okay, meaning so now machine type. So I want to create this machine type with E2 medium. So it creates with two CPUs and 4 GB of memory. Okay, so let me come here. So here you can see E2 medium comes with two CPUs and 4 GB of memory. So if you want to provide some another instance types, you can directly select here. Okay, so if you select here N2, so N2 comes with two CPUs and 8 GB of memory. Okay, so same like this you can directly select from here, and you can directly copy this name, and you can directly provide in your Terraform script. Okay, in machine type you can directly provide. Okay, so up to here this is enough. So this is the node configuration. So now still if you want to enable some auto scaling type of things for your Kubernetes cluster, you can directly select your auto scaling. So inside this, you need to provide the auto scaling details. So if you want to create with minimum nodes, which is 2, and let's select maximum node count, which is 5. Okay. So minimum it will create with the 2 node Kubernetes cluster, and mostly if our Kubernetes nodes are facing some traffic issues or some displeasure issues, automatically it will increase to 3, 4, or 5 depending on the requirement. Okay. So now management. In management, let me write for auto repair. Auto repair, let's select here true, so it will automatically repair. And auto upgrade. So auto upgrade also, let's select here true. Automatically it will upgrade with the latest Kubernetes versions. Okay. So these are the details we are going to provide for this. So it will create with the 2 node Kubernetes cluster. Okay. So mm, okay, so this is enough. So currently format is not good, guys. Okay. So if you want to keep this format in a proper way, directly open terminal. And Terraform FMT. So it will keep your code in a proper format. So here you can see all these 4 files kept in a proper format. Now let me validate this. Whether this Terraform script is valid or not, it will check. So here you can successful, the configuration is valid. So let me close this. So now I will explain you. So here you can see entire now proper, it has with the proper indentation. Okay, you can see now it has having the proper indentation. So using Terraform FMT, it will keep your Terraform scripts in a proper format. So now once I will explain you this entire Terraform scripts. So first we are going to create a VPC network with name custom VPC, and after that we are going to create a single subnetwork, and we are going to associate this subnetwork with this custom network, and we are going to create 3 different firewall rules, one for internal communication and one for SSH and ICMP and RDP access, and the third firewall rule is used for GKE communication. So one is for HTTPS and 10250 is used for kubelet API communication, and 15017 is used for control plane, istio control plane communication. Okay. So we are going to create these 3 firewall rules, and we associated these 3 firewall rules with our custom VPC. Okay. After that, we are going to create a Google Kubernetes engine. Okay. So we are going to create a 2 node Kubernetes cluster. So this is the thing. So let me uncomment this. Okay. So it will create with the latest Kubernetes version. Okay. So it will create this with this latest Kubernetes version. So if you want to, if you want to create with some another Kubernetes versions, you can directly provide that Kubernetes version. So previously, as I shown, you can directly get that Kubernetes versions from here. So okay, in target versions, you can directly provide any of this version. Okay. So it will create this Kubernetes cluster in that version. So now let me open this main.tf file, and this is the resource to create a container node pool. So we are going to create minimum 2 node Kubernetes cluster. So if the traffic is very high, it will increase to 3, 4, or 5 depending on the requirement. Okay. So now let me check this everything. So first let me select here VPC network. Where is this? So VPC network. Okay. So parallelly here, let's open GKE. Let me open this in a new tab. Okay. So here you can see we have only the 2 VPCs. One is default VPC and one is public VPC. So now for this today's video, we are going to create a custom VPC. Okay. So let me come here and let me open this GKE also. Directly select here clusters. So here you can see we don't have even single Kubernetes cluster. So now let's pin this everything using Terraform. So initially it will start with VPC, guys. Okay. So this is a private Kubernetes cluster, guys. Okay. So don't remember, don't forget that. So directly open terminal and run add to file. Let me select this. Okay. Now Terraform again plan. So Terraform plan is the command. It is used to show the resources what we are going to create. Okay. So here you can see currently we are going to create 7 resources. So these are the 7 resources. So first resource is last resource is container node pool, and before that we are going to create a Google Kubernetes cluster, and before that we are going to create a custom subnet, and before that we are going to create a uh, business container compute network. So this is the compute. Okay, so this is the VPC. So these are the firewall rules. Okay, so this is the firewall rule 1, and this is the firewall rule 2, and this is the firewall rule 3. Okay, so these are the things we are going to create it. Now let me hit Terraform apply hyphen hyphen auto hyphen apply. So this will create entire things using this Terraform. Okay, so now this state file will be stored in backend file, guys. Okay, so let me close this. So inside this terraform.tf state, it will store the Terraform state file inside Google Cloud Storage Bucket. So this Google Cloud Storage Bucket will act same like AWS S3. So in AWS S3, when we are working with Terraform, we use backend as AWS S3. So in the AWS S3, we will store all the Terraform state files, right? So same like this Google Cloud Storage Bucket is used to store all the backend state files. Okay. So now this Kubernetes cluster will create, it takes nearly uh, 10 to 15 minutes, guys. So mostly it will complete in 7 to 8 minutes. Sometimes it will create in 10 to 15 minutes. It depends on this configuration. Okay. So it got failed. So insufficient quota. Okay. It is throwing some issue. So it is throwing some insufficient regional quota and only 470 is available. Okay. So I think insufficient quota region. Okay, so in this region, it is facing some quota issues. Okay, so if you are performing this command, if you are running this code, you will not face these issues, guys. So previously, I worked with Google Kubernetes engine a lot, so that's why it is throwing that issue. So let me fix that issue. So minimum node count, I will change this to 1, and maximum node count, I will change this to 2. So here initial node count, let's change this to 1. So we are going to create it with the single node Kubernetes cluster. Why? Because means we don't have enough quotas. Okay, so let me change this to disk size to 1. So now in variable.tf file, let me change this node count to 1. I think we haven't provided this node count in this main.tf file. Let me check this where.node count. Okay, so we have provided here. Okay, so here also we're going to provide where.node count is 1. Okay, so this is fine. Var.node.conf. Okay. So already we provided in variable.tf file, right? So that's why I'm going to provide. So I'm going to provide with single node Kubernetes cluster. So if you are performing this, provide uh, that Kubernetes nodes depending on your needs. Okay. So currently we are going with single node Kubernetes cluster. Why? Because means we are facing some quota issues. Now let me run this file once again. So let's see now whether it will work or not. Now mostly I think it needs to work. So it is creating. So let me open this Google Kubernetes engine and let me refresh this. So here you can see Terraform GKE cluster it is creating. So here you can see 21% cluster has been created. So you can directly monitor from here. Okay. So currently we are going to create with a single node Kubernetes cluster only, right? So that's why it will create in less than, I think less than it will create in 10 to 8 minutes. So if you are going to create a very big Kubernetes cluster with more configuration and with more nodes like 5 nodes, 6 node Kubernetes cluster, it will take more time, guys. Okay. So I plan to create with a 2 node Kubernetes cluster, but due to some quota issues, it is failed. So here you can see insufficient quota regional. Okay. So this is the issue. So mostly in multiple times I use it to create a Kubernetes cluster. So I think that's why I have faced this issue. So try to create with a 2 node Kubernetes cluster, guys. Okay. So try to create with a 2 node Kubernetes cluster. Uh, with the 20 GB of disk size. And E2 medium for your practice, E2 medium is enough, guys. Why? Because means E2 medium creates with two CPUs and 4 GB of memory. Okay. So modify when you are working with this, modify these things. So change this minimum node count to 2 and maximum node count as your wish, and directly change this disk size to 20 GB, minimum 20 GB, guys. Okay. So E2 medium is enough for your practice. So it depends on your requirement, guys. So if you are going to run some large type of things, you can directly increase this machine type. Okay. So let's wait. Almost 1 minute 50 seconds has been completed. So let me come here. So here you can see 58% has been created. So I will skip this everything. Okay. So here you can see our Google Kubernetes cluster has been created successfully. Apply complete resources to added. That means Google Kubernetes cluster and a node pool. So if you check here, so let me select here clusters. So here you can see our Terraform GKE cluster has been created using Terraform, and inside this we have created a node pool. So why it has taken this much time? Means so almost here you can see uh, it has taken 11 minutes almost, and it is taken almost 2 minutes. Almost 13 minutes has been taken. Why? Because means while creating a GKE cluster. So here you can see. Let me remove this. So while creating this Google Kubernetes cluster, by default, it will create with a three-node Kubernetes cluster. So first this Kubernetes cluster has been created with a three-node Kubernetes cluster, and after that, by default, we have created a resource to create a node pool, right? So that's why it has removed that three Kubernetes nodes, and it has created with a single node Kubernetes cluster. Okay, here you can see currently we have only the single node Kubernetes cluster. So now let me connect to this Kubernetes cluster. Let me open this Cloud Shell. So I'm going to use this Google Cloud Shell itself only. Okay. So now first let me select here authorize. Will open meanwhile. So let me come here. So now if you want to see the resources which the Terraform has been created, so directly here search, uh, select Terraform state list. So this will list the resources which you have been created using Terraform. So here you can see all these resources has been created. Okay, firewall 1 and firewall 2 and firewall 3, and after that we created a custom network and sub network and a Google Kubernetes engine, and we created a node pool. Okay, so this is the entire Terraform script. So using this scripts we created. Okay, so let me open this. So now let me open this and directly select here connect. Okay, and copy this CLI command. Okay, so this command is used to connect to our Google Kubernetes cluster. Okay, so let me paste it here and enter. Here you can see 𝐿 container cluster get credentials. So this is the our name of the Kubernetes cluster, and hyphen region. In this region we created, and in this project we created. Okay, so it is successfully connected. Now let me clear the screen. Now kubectl get nodes -o white. Okay, so it is displaying two nodes. Great. And let me check it here. It is showing number of nodes 1, and inside that it is showing 2. So let me open compute engine. VM instances. So it has created two nodes. So let me check this code minimum. Okay. So it has created maximum node count. Uh, I think due to some network configuration. Okay. So anything is no problem. So let me come here. Uh, so here you can see these are the two Kubernetes nodes. So let me remove this. So now if you want to run any of the pods in this, so let me hit first pods kubectl get pods -a. So it will display all the pods. Okay. So currently we have all these pods in all the namespaces. Okay. So let me clear this. So now let me run a simple pod. So kubectl run pod hyphen image is equal to nginx. Okay. So we created a sample pod with nginx image. Now kubectl get pods. So here you can see a pod has been created in this Kubernetes cluster. Now if you want to describe that pod, kubectl describe pod and my pod. So here you can see successfully assigned default to my pod to a Google Kubernetes cluster. To that means to this node pool. And after that pulling image which is nginx successfully pulled image nginx and created container. It is created and it is started container. So this is the events. So you can find all the pod details here. So let me create this now kubectl get pods. So if you want to see the logs for this kubectl logs -f and my pod, so it will display the pod logs. So -f stands for live logs also. Okay. So sorry, here we need to remove get. Okay. kubectl only logs. So -f stands for live. So it will display live logs. So if you are not providing -f, it will display only the current logs. Okay. So it will not display live logs. So here you can see it is stopped. So now if you want to see the YAML kubectl get pods, kubectl get pod. So it got stuck. So let's wait. Okay. kubectl get pod my pod -o YAML. So here you can see this is the pod YAML. Okay. So same like this you can get guys. Okay. So now kubectl get pods. So if you want to enter into that pod kubectl exec -it and you need to give the pod name as my pod --/ bin /bash. Okay. So this is the command to enter into your pod. Let's wait. So here you can see now currently we're in inside of the pod. So now if you hit apt update, it will update this pod. So same like this, you can do all the actions, guys. Exit, okay. So if your pod is in some other namespace, you can directly, if you want to enter into that pod, you can directly hit this command kubectl exec-it pod name --/ bin /bash and -n. You need to give the namespace name, okay. So same like this, instead of this, you need to give your namespace name. So now let me clear this screen kubectl get pods. So if you want to delete that pod, kubectl delete pod, and you can directly delete that pod, which is my pod. So if you select kubectl get pods, we don't have any pods. So here you can see we don't have a single pod. Now if you select here kubectl get services, it will display only the default service. Okay, so here you can see this is the Kubernetes default service. So kubectl get deployments, it will display all the deployments. Sorry. So here you can see currently we don't have any other single deployment. So if you want to create a deployment using this command line, kubectl create deployment, and let's give the deployment name like my deployment and image as nginx. And if you want to give some specific number of replicas, you can directly provide this. Replicas equal to 4. So it will create a deployment with nginx image and with 4 replicas. Now kubectl get deployment. So here you can see my deployment has been created with 4 pods. Okay. So kubectl get pods. So here you can see 4 pods has been created using that deployment. Okay. So now if you delete a single pod automatically, again that deployment will be created a new pod using replica sets. Why? Because means we have created with 4 replica sets, so always it will maintain 4 replicas. Now kubectl delete pod and directly provide this pod name. So I'm going to delete this pod. Now kubectl get pods, automatically a new pod will be created, guys. Okay, here you can see 3 seconds ago a new pod has been created. Why? Because means always replica set will maintain these 4 replicas. Now if you select kubectl get rs, so using that deployment a replica set will be created. So here you can see this is the rs replica set. Rs stands for replica sets. Okay, this is the my deployment replica set. So when I select here history, so using this command, we created a deployment, right? So we created a deployment with 𝐵𝐨𝐺𝐸 and we created with 4 replicas. So that's why uh, a replica set will be created in background. So this replica set will maintain 4 pods constantly. Okay. Now kubectl get pods. If I try to delete some another pod, kubectl delete pod. So if I try to delete this last pod, automatically again, replica set will create a new pod. kubectl get pods. So here you can see a new pod will be created. Here you can see 4 seconds ago a pod will be created. So this is how it will maintain constantly. Now kubectl get deployments. So if you want to delete the deployment, kubectl delete deployment, my deployment. So this is the name. Now kubectl get deployment. So we don't have any deployment. kubectl get rs. Replica set will be terminated, guys. That means it will be deleted. Why? Because means we have deleted deployment. So here you can see we don't have replica sets. kubectl get pods, or we don't have even single pod. Here you can see no pods. Why? Because means we deleted that deployment. Okay. So kubectl get nodes. So these are the Kubernetes nodes. So with the latest version only we created 1.31.6. So if you observed in Terraform scripts 1.31.6. Okay, so this is the Kubernetes version we created. Okay, so and yes, that's it for today's video. So in this video I just explained you how to create a Google Kubernetes engine using Terraform. So due to some quota issues I faced some issues. So try to maintain always minimum 2 to 3 pods. Okay, sorry, 2 to 3 nodes. Okay, so directly in variable.tf file here provide if you want to create a 2 node Kubernetes cluster, directly select here 2, select 2. So if you want to create 4 node Kubernetes cluster, directly select here 4. So okay, so if you want to create in any of the specific Kubernetes version, you can directly specify that version here. Okay, so if you want to always create with the latest Kubernetes version, directly this master version, and here this node version, directly comment this. Always Kubernetes cluster will be created with the latest Kubernetes version. Okay, so let me remove this. So and after completing this, so if you are continuously if you provided here minimum node count as 4, minimum node count as 2 in main.tf file, in auto scaling directly select here 2, and max node count directly select here 4 or 5 or 6, that is up to your wish. Okay, so let me select here 1. Okay, so now I'm going to destroy that entire resources. So before destroying that, I think I haven't shown you the custom VPC. So let me come here. Let me select here VPC network. So here you can see a VPC has been created. Inside the subnet will be created, and firewalls. So here you can see custom subnetwork has been created, and firewalls also will be created. Drop down this. So here you can see these are the firewall rules we created. Okay, this is how you can create a private Kubernetes cluster using Terraform. So this is a private Kubernetes cluster. Okay, so now let me terminate this Kubernetes cluster using Terraform itself. So simple command, guys: Terraform destroy hyphen auto hyphen approve. So this command will destroy our entire resources now. Okay, So here you can see it is refreshing this entire state, and after that it will remove entire node pool Kubernetes cluster and VPC subnetworks and everything. So here you can see 7 resources it is going to destroy. So okay, after once again I'm telling you, after destroying your entire resources in IAM, so directly jump on to IAM and directly jump on to service accounts and directly select your GKE service account. And inside this, previously we created inside keys, we created a JSON key, right? So this is the JSON key. So after completing your practice, directly delete this JSON key. So if you are providing this JSON key to some other people, that people can use directly your Google Cloud account. Okay, you please don't forget that. So here you can see currently node pool is currently it is in deleting state. So let me come here and let me refresh this. So here you can see currently it is in stopping state. That means it is currently it is deleting. Okay. So here you can see currently it is created with the two node Kubernetes cluster. Why? Because means some it depends on CPU and memory utilization. So that's why I think it is created with the two node Kubernetes cluster. Here you can see nodes 2. Okay, we enabled auto scaling, right? So here you can see auto scaling. Current first it will create a single node Kubernetes cluster. So so if it required some CPU some resources, it will increase to two node Kubernetes cluster. Okay, so in main.tf file we have provided like that. So you can see minimum node count 1, maximum node count 2. Okay, so this is how it will continuously maintain. So let's wait. After destroying this, I will fast forward this everything. Okay. So here you can see entire 7 resources has been destroyed successfully. So let me hit Terraform state list. So here you can see we don't have even single resource. Okay. So all these resources has been terminated. Custom network and this custom subnetwork and these 3 firewall rules and GKE cluster and a node pool. Everything has been destroyed. So let me come here and let me refresh this. So here you can see in clusters we don't have even single Kubernetes cluster. And let me jump on to VPC network. So here you can see we don't have custom VPC. Okay. So inside that custom VPC only we created subnet firewalls and everything, right? So that also everything will be destroyed. Okay. So and yes, that's it for today's video. So at last, try to delete your service account credentials, guys. So again, once again, I'm telling you, you can directly jump onto IAM and directly jump onto service account and open your service account. So this is the service account, GKE service account, and directly jump onto keys, directly come down and directly select your delete and delete. Okay. So now this token will be deleted. That means this JSON key will be deleted. So now now this JSON key will not work, guys. Okay. Why? Because means we have deleted that service account file in our Google Cloud account. So now if you want to delete this GKE service account, directly select this and delete and delete. So now totally service account also will be deleted. Okay. So after completing your labs and everything, try to delete that, guys. Okay. So if you are using your personal account, you can directly keep that with you. So if you are using some other accounts, so try to delete the service account credentials. Okay. And yes, that's it for today's video. And if you like my video, please do like, share, and subscribe to my YouTube channel, guys. And see you in the next video. And bye.